Hello. In this chapter, we're going to introduce Fourier analysis of signals. So in this chapter, we're going to break the content into 4 parts. First of all, we want to introduce why do we have to use frequency analysis of signals. We already learned that in the continuous time domain, for any LTI systems, we can analyze the system's property and the input and output. So assume that the input signal can be broken into a linear combination of delta function and its time shift, and that the response of an LTI system to delta function is the impulse response h of t. Then the output of the system can be represented by this equation. We call this convolution. So this is a beautiful theory to introduce the interaction between the signals and systems. So we already know this very clearly. Why do we bother to use another way, frequency analysis of the signals? Well, there are a few difficulties in the time domain to do signal analysis. For example, in here, there's 2 different vocal voices. And this is the second one. We can hear the difference clearly, but if I show the waveform in the time domain, you can see they're very much similar. So although we can tell the difference using our ears, we cannot really describe the difference in the time domain very clearly. In the second example, when we dial a phone number, how does the telephone company understand which one we're trying to reach? Well, we can use phone numbers. How can the telephone company can tell the numbers? Well, here are 2 sounds. This is for number 1, and this is for number 2. And clearly, we can hear the difference. But again, if I show you their waveform in the time domain, it's kind of hard to quantitatively tell the difference between these 2 waveforms. Well, in the third example, we can hear there are 2 different signals. The first one. It's a very clear sound. What about the second one? Well, we can hear that in the second signal, there's a noise in there. And if I again show you guys the time waveform of these 2 signals, well, it's kind of hard for us to tell the difference quantitatively. So in this chapter, we try to introduce some more tools in the frequency domain, can help us make these 3 tasks quite simple. We can use some straightforward method to help us solve the problems in these 3 examples. So in this chapter, we want to reach these objectives. First of all, we want to explain clearly how we can use Fourier methods to represent signals. And students are expected to understand the concept, the definition of frequency spectrum. And based on that definition, students are expected to calculate the Fourier spectrum using the definition. And we need to understand the properties of Fourier transform. And during the introduction, we want students to notice the correspondence between the frequency and the time domains. Thank you.